Hello people of YouTube. This is a method that's been around a while. Chopped off bit of printed circuit board. Wherever there's a black dot, first one. Of course, super glue reacts very quickly. So you don't really get a second chance. So everywhere there's a black dot on the printed circuit, on the actual printout, is where we put glue. This is actually it's double-sided plain printed circuit board, and it's the actual fiberglass version rather than resin bonded paper. I'm under the impression that the resin bonded paper printed circuit does actually stick a lot better. The actual bond between the copper clad and the glass fibre is better. It does mean that you have to use a particular saw blade in a circular saw to cut glass fibre printed circuit board, because it will, the ones that are made for cutting wood won't really survive for very long, as glass is a very hard material. And there's another upload of mine where I leave instructions on how to sharpen a circular saw blade, if anyone's interested. Just look elsewhere on my channel. This is a Glissade project. So a Glissade means, I think it means slide in German word for slide. And variable tone generator. Now, there's a band called Hawkwind, who I really love, and found out, unfortunately, that poor old Dick Mick, the original guy in Hawkwind who played the Glissade, or the tone generator, died. But that's life, unfortunately. That's the way the cookie crumbles. So this is a slightly thinner one. Same stuff, glass fibre. There's probably a name for the glass fibre printed circuit board. Of course, when I started doing this sort of thing, building electronic circuits from books, borrowed from the library usually, we used to build them on Vero board, and very often the circuits wouldn't work. Now, it usually is because a mistake has been made somewhere. usually an uncut track or something like that. And what I should have done is stayed, when I was very much younger, stayed with the that was drawing pins on plywood. That's how we used to do it years ago. And fortunately the plywood, or any wood, has got a low resistance, so it's not ideal for the purposes of building electronic circuits, because the actual wood itself conducts electricity a little bit. It's in the order of tens of megohms, but it does upset circuit function. And as opposed to jumping straight into variable when I was very young, I should have stayed with this means of construction, just to build up my self-confidence and that. So any circuit, more or less, can be built like this. Obviously, don't expect it to fit into a small box. It will be quite spread out. But we must remember that if a device like a radio set or a battery guitar amplifier, which I built quite a few of, what they do is they need a lot of space anyway, so the sound moves well, you know, so you get a lower resonance, feels guitar. And what you'll often get is a little printed circuit stuck in the corner somewhere, where if the components were more spread out, it would be more repairable, much easier to repair. Should have done a black dot there, so I'm going to fit it in anyway. There we go. So everywhere there's a black dot, I'm actually gluing on a piece of printed circuit board. I actually have two sizes of chopped off printed circuit board. It's convenient if you know there's not going to be a lot of wires connected to one of the junctions, and these black dots form the junctions, or the nodes, as they're often called, points of reference between component connection and that. Anyway, I might have been explaining that Dick Mick was the audio generator operator in Hawkwind, UK, and anyone doesn't know what Hawkwind is, you know, some people might not. It's one of the original space rock bands, so it was like brilliant rock on a space theme. Of course, the Lemmy-God was also in Hawkwind. He played bass and sang the words to Silver Machine. It's one of the problems with working with super glue, is it does tend to it's inclined to stick to you as well as whatever you're trying to stick. So I'm just going to just clean this up a bit. You have to clean this printed, see my printed circuit board is a little bit dull, as you can see, and I needed to bring it up bright copper. But if your printed circuit board is sitting in your shed, like mine is, usually you find that it gets a little bit tarnished, and it won't take solder connections very well. and it won't take glue either as well, super glue. I've put an on-off switch in the circuit because it might be a good option for somebody who but normally you just, if you don't want to fit a switch, you just put a piece of wire across there instead, and then use the connection or disconnection of the battery as a means of on-off. So that's all of the nodes done. And the idea is you can, if you're interested in building via this means, and it's very good means if you want to learn. I mean, obviously you can just buy a kit, printed circuit board already made up, and you pop your components in and you solder them. But via this means, it's a good way of learning how to translate a circuit diagram to a working apparatus, rather than just buying a printed circuit board. I mean, anyone can do that. This is more of the core studies, and it's kind of closer to the original concept of building stuff in electronics. So in this we'll need a 47 ohm resistor, 150 k ohm resistor, a 10k resistor, a 100k resistor, another 10k resistor, a 12k, and a potentiometer, which is 100k. Okay, listen out for part 2. This will be a continuation. Hello YouTube Pixies. This is a continuation of this glissade. So, commence with the old soldering. What people don't seem to realise is you can't use solder as glue. You basically heat the surface up that you're trying to solder and apply the solder to the actual device. That makes sense. So because it does mean you have to be a little bit dexterous at times. So there you go. That solders onto there like so. Now if you're wondering what that noise is, anyone in the back, there's noise in the background, anyone wondering what it is actually a fan, an extractor fan I'm experimenting with, as I have an extreme allergy to solder fumes. So hopefully the fan is going to suck the fumes away, with any luck. Now, you might pick up information from other YouTube channels about the sensitivity of transistors to soldering. It doesn't happen. It is in fact very difficult to destroy a transistor with a soldering iron. I think they only said that years ago because transistors would cost about a day's wage. Originally they were very, very expensive, and of course and these are, anyway, on my website I described the resistors, as I said, I think, or maybe in the previous channel, the previous bit of this movie. 8 ohm speaker, 47 ohm resistor, 150 k ohm resistor, 10k, 100k, 10k resistor, 12k, and then a potentiometer. All the capacitors are 0.02. Now the original source of this circuit was projects for electronics projects for beginners, and this is the Glissade. Now I built this exactly as they said, and it didn't sound any good. Now I think the HFE of the transistors is slightly higher, and I think that may affect the time constant of the resistor capacitor combination. So unfortunately I've had to change a few of the component values to suit. All the transistors are BC337, but almost any general purpose transistor would work. Got a little box of BC337s here. BC337. Should just be able to see that. Now when this schematic is printed out, as far as I'm concerned, if it's an A4 page that you're printing, that would be correct. So in actual fact it was necessary for me to design the circuit, photograph it or scan it in, and then change the orientation so it would print out properly to portrait. So I printed it out from Microsoft Word. Now this fan system seems to be working extremely well. I mean, my allergy, especially as someone who's hobby electronics, to have an allergy to solder fumes is a considerable disadvantage. In actual fact, it gets so bad that I actually lose sleep. So I wake up fairly early in the morning while I should be asleep, and I start sneezing and blowing my nose and constantly, and it carries on like that for about an hour, and then I get back to sleep. Now unfortunately I'm on amlodipine. Why doesn't this focus? I think that's better. Amlodipine for blood pressure. So not allowed to take any anything with what they call it, phenylephrine. Been advised by the doctor not to, or the pharmacist I should say. Nobody sees a doctor nowadays in the UK, but by the pharmacist I was advised, whatever you do, don't take phenylephrine, or however you spell it or pronounce it. Bit of a pain, but it's just, that's life, I'm afraid. It's just the way it goes. So I'm going to snip that there. Sometimes I fold this thing over as a means of giving it a little bit more surface area. That's a habit I got from working for Holdreman Engineering in the 1970s. And I was taught to solder. I already knew how to solder, but they reinforced it, if you like. So this lead is so long that I can use it to make another 2 connections there, like that. It's perfect, it's lovely. That's all the transistors soldered in, and now it's time for the capacitors. So we'll put the transistors away. And we need, how many? Two more of the 0.02. Yellow, when you're reading transistor, always work from left to right. Yellow, 4, purple, 7, and no zeros, 0 zeros. That's the multiplier, 47 ohms. Well, I'm pleased to say that my solder fumes extractor, which isn't actually extractor, what it is, it just sucks the solder fumes away from the work, goes straight out into the street, or my garden actually, so that's no problem at all. I mean, you know, it's not going to cause any harms out there, is it? So, you know, so this 100k, it's a good idea to learn the colour code off by heart. So we've got brown, which is 1, black, which is 0, so that's 10, followed by 4, because yellow is 4 zeros, 100,000 ohms, 100k. Kilo. There seems to be kits for everything, just about everything made in China these days. If you want an amp on the quick and you don't want to mess around, they've got a very good value. Something like less than 5 UK pounds, you can get an LM386 amp kit, and they're very, very reliable. Very rarely do they actually not work when they're built. And the other thing about those kits that you get from China is they always use a socket for the printed circuit, so can't really go wrong. The problem with using one of those kits is you don't really learn anything about circuit diagrams and circuits generally, whereas this method here is more or less a way of teaching people who've never done any electronics construction, a means by which they can transfer a circuit diagram onto a working piece of apparatus. In case you're wondering, this is wire they used to use for the BT telephones. It's basically solid copper with a plastic with insulator, obviously. Okay. And it is possible to buy copper wire that's hasn't got any plastic around it. It's just that happens to have loads and loads of it, so just make it more convenient. Of course, one of our problems in the UK is that we've lost Maplins. They went bankrupt, which is a big problem. Never mind, eh? Mind you, they were expensive. Okay, of course for me that was a few seconds. I've got this stuff called double-sided sellotape, double-sided adhesive tape, and I'm going to do is stick, it's an old folder from one of those folders with the London Underground typed on the back of it, printed I should say. So just to make it stay where it needs to stay, I'm going to use a bit of this double-sided tape, and it will stop jumping around with any luck. So how I've actually joined, hope it sticks, yeah, okay, let's turn that out that way. So this double-sided tape should point out that this is actually a printout from www.hoofbags.me.uk, and you can find this circuit on the page called Geeky Stuff. You go from there, you'll find a picture of this. You click on it and that will lead you to a printout that you can print out using Word for Windows, and it's actually an A4 that it prints out, and you cut the top off and then you use the double-sided tape to stick the actual printout onto a piece of card, or wood if you prefer, or metal. Now in order to make sure the thing turns out, I make a reference. So for example, between any 2 points, let's pick any 2 points. Right, let's take TR1 collector, which is there, TR2 collector, and we've got 42.53 millimeters. Now if it comes out smaller, that's not a problem, a little bit smaller, but it just means that you have to cram these copper islands closer together. If your printout comes out much bigger, then you'll have to stretch the component leads to reach the nodes. So it's a good idea to make it so it prints out 42.5 millimeters. between these two collectors. Now there's a little symbol there, looks like a horseshoe. That means it's wires crossing but bridged over, okay? Peeled the plastic off that. Just peeled the plastic off it because we don't need the plastic. It is important that this join here, these must be kept apart. This here is a 100k potentiometer. In fact, I wrote on the back at some points, I wasn't sure what it might have been, 126k. Potentiometers very often don't seem to be what they say they are. They're usually a bit sort of like 20%, even 30% off. So it's always a good idea to measure it, just in case there's a mistake in the factory, and believe me, they do happen. So I'm connecting to the two outer ones, and there's the other one. The middle one is called the slider, so we've got 128k, so that is a standard 100k potentiometer, and it's a used one. I'm using a spanner from a bicycle in order to hold the potentiometer while I solder the connections. So this is a Lin pot, a Lin potentiometer. Now, interesting thing about a glissade is you can either have, so it increases in pitch as you turn clockwise. So you start anti-clockwise for low pitch and gradually increase the pitch by turning clockwise, in which case you use this, that's the preferred method, but in this case you use this plug here, this lug. If you wanted it so that the frequency decreases the further you turn it to the right, clockwise I mean, then you would use the other lug. Shot of that, we've used it, so we go. Just cut that like that, and solder it like this. That's it, and tin it and everything, as you do. Tin it, there you go. Bring it back over here. Okay, now now we could say 3 parts of the potentiometer. This is one end of resistor inside the potentiometer, and that's the opposite end of the resistor inside the potentiometer. And then this middle one is the slider. It's a sliding lug, so you can vary the resistance from practically 0, increasing to in fact, I've just mentioned that I've put it the wrong way around, so I'm just going to correct that. So we want to, right, we want to low tone, low pitch, higher pitch as it turns clockwise. So I'll just sort that out. Silly sausage, that's me. So wired like this, it means this will be the lowest pitch at this end, and then you'll increase the pitch of the glissade by turning clockwise. Now this potentiometer symbol here, it actually assumes that one end of these is connected to the centre. If you just joined the two the outside ones, that one and that one, to there and there, it won't do anything, it won't vary, it'll make a noise but you won't be able to vary the pitch. So it has to be one end of the potentiometer and a middle lobe. That's an 8-ohm speaker taken out of an old radio or something similar. We'll connect the wires. To the speaker terminals of our circuit board. One battery connector. Wrong place, sorry, goes there. That's positive of the battery, and that's negative of the battery. That's here. Cheapest and simplest switch in the world. Not necessarily the most convenient, but it certainly works. Okay, so we've got 2 lumps of wire like that. Okay, simplest and cheapest switch in the world. There we go. So we solder that in there like that. Solder that end like that. One goes there. The other one goes there. Of course, it would be much nicer to use a proper switch, or even a Morse code key. So you join the wires together to make it work, and separate them to stop it making a noise. Poundland, UK. Right, that's one thing I've forgotten. Right, that is a 150k resistor, and it goes between collector and then to base. There we go. Fingers crossed. Usually need them. Let's set the potentiometer about halfway, just for hopes. And it doesn't work. Yes, it does, because we haven't. There we go. Of course, probably getting a bit of drowning out with this thing going on. Bit louder. Right, and there's one tune that they often do. I think it's Mullen Kintyre or something like that. One of these tunes they use. Obviously, it takes a bit of practice to get it right. Let's have a think of other tunes. How about? I mean, I personally feel that using a glissade for this purpose is a bit of a waste. If you feed it through an echo machine, you get Hawkwind style effects. We turn this into a instant Morse tapper. Let's think of a tune. How about let's try the EastEnders tune. I'm hopeless at this. Anyway, thank you for paying attention and watching our movie. Very, very grateful for you watching. Hopefully I've helped you learn a bit more about how to convert a circuit diagram into a working piece of apparatus. So thank you for watching.